All right, in this video, we're going to learn about some special cases in factoring. And these special cases, if we recognize them, can make our life a whole lot easier. So the topic for today is special cases when factoring trinomials. Or maybe just factoring, because it doesn't necessarily have to be a trinomial. And the objective is going to be that we'll learn how to factor in two special situations. So we'll be able to factor when given a trinomial that is a perfect square. So that is one of our objectives. Okay, so if we see a trinomial that is a perfect square, we'll be able to factor that, and we'll learn a technique that makes it a little bit easier. And, okay, so there's two objectives here. We'll be able to factor a difference of squares. Difference of squares. Okay, and that's not actually a trinomial, but it could be written as a trinomial if you want. But anyway, if we see difference of squares, we could write as a trinomial and use our usual techniques, but there is a shortcut. We're going to learn those shortcuts. So think of these special cases as shortcuts. All right. So the first thing we want to look at is perfect squares. Okay, what is a perfect square? What do we mean by perfect square? And how do we factor it? Okay, so when we say a perfect square, what we mean is it would be, instead of two binomials being multiplied together that are different, we have two binomials that are being multiplied together that are the same. So that's what we mean by perfect square. So let's just take a look at this example. We have the binomial 2x plus 3, and it is multiplied by itself. So by definition, that means it looks like this: 2x plus 3 times 2x plus 3. Okay, so we have two binomials multiplied together, but a perfect square would be a situation in which those binomials are identical. So it could be written like this, or it could be written like this. They mean the same thing. All right, so if we multiply that out, let's see what we get. Following our first, outer, inner, last, we get 2x times 3. I'm sorry, 2x times 2x. Start with our first, 2x times 2x, and then plus 2x times 3, and then plus 2x times 3 again, or 3 times 2x, and finally plus 3 times 3. Right, what you end up with is 4x squared plus 6x plus 6x plus 9. And then we simplify by combining like terms, and we get 4x squared plus 12x plus 9. All right, so this is a perfect square, and when we multiply it out, this is what we get. So the question is, how do we factor that? How do we go backwards? How do we go from here back to here? Okay, so what is the trick? What is the technique? Well, before I tell you what the trick and the technique is, what I want you to recognize is this: that we end up with our middle terms, 6x and 6x. That those middle terms look the same. And why they look the same is because when I take 2x times 3, which is our outer, I get the same thing as 3 times 2x, which is our inner. And that'll happen every time that you have a perfect square. The outer and the inner will always be identical. So these two terms will always look the same. As a result, we end up with a certain pattern here. And the pattern is this. Notice that the 4x squared came from 2x times 2x, and the 9 came from 3 times 3. Okay, so what happens is, let's give some names to these things. Let's call the first term A and the second term B. So now I'm going to generalize. I'm going to say A plus B squared. Okay, and what I want you to see is that this 4x squared, this was going to be the first term, which is A squared. So this is A squared. And this last term over here, 9, okay, maybe I will make this a little bit more obvious by boxing it. This last term here, 9, it's going to be the same thing as the second term, b squared. Okay, so we end up with a squared and we have b squared. And then how do we get that term in the middle? Well, look and see where it came from. It came from adding two of the middle terms together, 6x plus 6x, and those two middle terms were identical to each other. And one of those middle terms comes from multiplying a times b. So this right here is a times b. Okay, it's 2x times 3, that's a times b. And this is 3 times 2x, that's a times b. So what ends up happening is we end up multiplying a, b together, and then we multiply a, b together again, and we end up adding two versions of a, b together. So this box right here ends up becoming 2ab. So we actually have a pattern here whenever you have a perfect square. And the pattern is that it'll always take the form of a squared plus 2ab plus b squared. Okay, so if we recognize that we have that pattern, then we can take advantage of the shortcut. So that is the general rule. Okay, if you happen to recognize that pattern. But you do have to recognize that pattern in order to be able to do that. So let's take a look at maybe if you were given this problem, if you would recognize the pattern. All right, so if you get a situation, and I'll go back to the same example, except this time I will try to go backwards with it. All right. Okay, so this time we're going to try to go backwards with the exact same example. So let's say we were given the 4x squared plus 12x plus 9, we were told to factor 4x squared plus 12x plus 9. Well, if you didn't immediately recognize that this takes on the form of a squared plus 2ab plus b squared, you'd probably do something like this. You probably would set up your diamond or X or whatever you want to call it, and recognize what goes on the top is AB, and AB is 4 times 9 is 36, and what goes on the bottom is B, and that's 12, and you say, okay, and this is positive, this is positive. You'd say what plus what is 12, and then those two numbers are also multiplied together to give you 36. You might recognize that it's 6 and 6. So if you get this situation where these two numbers come out the same, that would be a good time to check and see if you have the form of a perfect square. You ask yourself, what is the square root of this? And so the square root of 4x squared is going to be 2x. You ask yourself, what is the square root of this? I guess I don't need to draw an arrow on that one. Square root of 9 comes out to be 3. And then you ask yourself, okay, now that I know what this is and this is the middle term just going to be 2 times this? So I say, what is 2 times 2x times 3? And if it comes out to be the same as this right here, and it does, then I know that we have the form of a squared plus 2ab plus b squared. So if I have the form of a squared plus 2ab plus b squared, then I know it's going to become a plus b squared. So in our situation, we know what a is because I found it. We know what b is because I found it. So the answer is going to be, and I can just write it right up here, it's just going to be a plus b squared. All right? So that is the process that we go through if we have a perfect square.